and we will use a lot in here. And if you have to take more math classes, it comes up frequently. It's one that's just important enough you really should know it. So, you do have to know this one. So remember, that's when you have a quadratic of the form ax squared plus bx plus c equals 0. Then a is just your coefficient of x squared, b is your coefficient of x, and c is your constant. Unlike slip and slide or completing the square, it doesn't matter what the coefficient of x is, or of x squared. It doesn't have to be a positive, it doesn't have to be 1, it can be anything. And we'll get our answer. So let's take a look. What do I need to do first? Okay, so we would try slip and slide probably first. Does anything multiply 2 and add -4? No, so it doesn't factor nicely. We could do completing the square like yesterday. The other option is quadratic formula. A is the number in front of x squared, so that's a 1. B is the coefficient of x, so that's -4. C is the constant, so that's 2. So the formula, x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. That's what we're plugging into. So the opposite of b, opposite of -4 plus or minus the square root of b, so -4 squared minus 4 times 1 times 2 over 2. So under my radical I get 16 minus 8, which is 8. Can we break down the square root of 8? Mm-hmm. 8 is a 4 times 2, so that's 2 radical 2. And what else could we do? Divide everything by 2. So we get 2 plus or minus the square root of 2. Let's do another one together. What do I do first? Okay, so we can bring over the x minus 4, so that would make it a minus x and plus 4. It's also okay if you bring over the 2x squared. It doesn't matter in the formula if a is positive or negative. We get the same answer. So if I do it this way, my a would be 2. B is c is x equals, the opposite of b would be 1 plus or minus square root of b squared minus 4 times a times c all over 2a. Under my square root, I get 1 minus 32, so that's a negative 31. What can I do with that? Take out an I. Then because it is, oh, hold on, I added a negative out of nowhere, didn't I? Because it is imaginary, we do need to break them apart for the final answer, so it's in standard form. So just 1/4 plus or minus I radical 31 over 4. Is that okay? All right, let's see if you guys can get one. So here's your problem. All right, so we have to bring over the 5. Is that what everybody did? So if I set it up like this, my A is -3, my B is -2, and my C is 5. It's just the numbers, no variables. If you moved everything to the other side, your A and C would have opposite signs. So +3, +2, -5. And you'll get the same thing at the end. So x equals the opposite of B. So the opposite of -2 is +2. Plus or minus the square root of B squared minus 4 times A times C all over 2A. Okay, -2 squared is 4. -4 times -3 is +12, plus 5 is 60. So we get the square root of 64. What is the square root of 64? We can finish this because they're all like terms. This means you have 2 plus 8 divided by 6 and 2 minus 8 divided by negative 6. So 2 plus 8 is 10 divided by negative 6. 2 minus 8 is negative 6 divided by negative 6. So negative 5/3 and 1 are the only answers. Right. Do we need more practice using the quadratic formula? So, let me ask a question. How do we know if we get real or imaginary numbers? What determines that? If we end up with a negative under the square root, we get imaginaries. Otherwise, we get real answers. What would happen if I did a quadratic and let's say I got 5 plus or minus 0 over 2? What's 5 plus 0? So 5 divided by 2. What's 5 minus 0? 5 over 2. So what happens in that case? We really just get one answer with a multiplicity of 2. So most of the time, we get 2 answers. We could just get one answer if that were a 0. They're real answers if it's a positive. They're imaginary if it's a negative. That's what's called the discriminant. So you guys do need to write this down. If you are asked about the discriminant, that is the number under the square root. It does not include the square root itself. So just the b squared minus 4ac. When you're doing that, if it's a positive, you get 2 real solutions. If it's 0, you're just getting 1 real solution. And if it's a negative, it's 2 imaginary solutions. We're also going to see sometimes we get answers that still have radicals in them. But like that last example you guys worked, it turned out nice. So those nice numbers are called rational numbers. Why did your answer turn out nice? Why did you get rational numbers here? There was no imaginary, and this was a perfect square. So we might also ask you if you're going to have a rational or an irrational solution, and it's just based on if that's a perfect square or not. If it's rational, it's perfect square, so we get rid of the square root. If it's irrational, it's not a perfect square, so the square root stays. So let's look at a few examples of this. I want to describe the number and the type of solutions. So I'm not saying you have to solve it. I just want to know how many answers are we going to get, what are they going to look like? Which means all I need is that discriminant, b squared minus 4ac. So on A, what is my b value? 5 squared minus 4 times, what's A? 3, and what's C? So we get 25 minus 12, which is 13. So my discriminant is 13. What does that tell me? It's irrational because it's not a perfect square, and it will be 2 real solutions because it's a positive. So we have 2 real irrational solutions. When I solve it, my answer will still have a radical in it, but I will get 2 real answers. All right, when I look at B, what do I have to do first here? Has to be equal to 0. So if I subtract my 1/2, okay, b squared minus 4ac. So b is negative 1/4 squared minus 4, a is 3/4, c is negative 1/2. So that's 1/16 plus 3/2, which is 25/16. What does that tell me? It's 2 real because it's positive. What else does it tell me? Rational. Can you do the square root of 25/16? Yes, so it will be rational. We'll get nice answers. Okay, you guys do one. We need to subtract over the 4x. Remember, a, b, and c is based off ax squared plus bx plus c. So the 4x is in the middle. So b squared, so negative 4 squared, minus 4 times a times c. So we get 16 minus 24, which is negative 8. So I'm getting 2 answers. The only time we get 1 is if we get 0 out. But what kind of answers are these? Typically, rational, irrational is only used with the real numbers. However, if I asked, is 8 rational or irrational? Irrational. Good. All right, any issues with that? Okay. The last thing I want to do, we're just going to do a couple examples and then I am finished. I want to talk a little bit about what this stuff tells us about our quadratics. We know that our quadratics can open up or down. What's that based off of? Right. So if it opens up, the a is positive. If it opens down, the a is negative, right? If you have a parabola, okay, it's possible that it hits the x-axis twice, that it has two x-intercepts. That means it has two real solutions. So what's true about your discriminant if it has two real solutions? Not bad. If you have two real solutions, that means it was greater than 0. So we know a little bit without ever going through the process of solving these. Like if I look back at A, can you tell me, does this parabola open up or down? Up. It has two real solutions. So solutions are when you cross the x-axis. So I know this parabola opens up and it hits my x-axis twice. We know a little bit about our graphs. If the discriminant is 0, then how many solutions do we get? 1. So in terms of the graph, that means it touches the x-axis 1 time. So that's like our normal x squared. Positive still opens up, negative still opens down. The other option, we might have a parabola that never touches the x-axis. What would cause it to never touch the x-axis? So if your discriminant is negative, your answers are imaginary. So in terms of our graph, that means it never hits the x-axis. So we know a little bit about the shape of our graph, and this is going to be helpful when we move into the next few sections. All right. Any questions there? Last thing I just want to see, can you manipulate an equation and solve for a variable? So if I said a equals pi d squared divided by 4. Can you solve that for d? Good. So first step, get rid of the fraction. Multiply by 4. So 4a equals pi d squared. Now what? So 4a divided by pi equals d squared. Yep, and then you have to add a square root. If you add a square root, what else do you need? So d is plus and minus the square root of 4a over pi. All right, you guys do one. If we get it, then I'm done. Everybody try this problem. How do we cancel the 1/3? So 3b equals pi r squared h. All right, I did see a couple issues with the h, but all of this is multiplied together. So we could get rid of it just by dividing by everything we don't want, which is the pi and the h. So that means r squared is 3b divided by pi h. So then to get rid of the square, r is plus or minus the square root of 3b over pi h. So quiz tomorrow, which we've talked about, what will be on there. There is a math Excel assignment open. If you don't have yesterday's done, make sure you're getting caught up. You have the rest of the hour to work.
b squared minus 4ac.
Just that. Well, like what we were doing at the end. So, just that calculation. So, when you look at it again.
I'm such a number.
Okay. When you bring over your 13.
Oh my gosh, is that from Carson and
Yes. So excited.
It's not diet.
It's okay.